session will focus on space efficient solutions. So we will explore different approaches on how to manage water resources in urban areas. And we will start with Paula. Paula will present some cases from North America on how we can accelerate the use of on-site water treatment. So she will present us some systems across North America. And of course, since we are talking about space efficient solutions, we are also going to focus on examples that are related to urban settings. And then we are going to move with the next speaker, which is Stina from the Oslo Commune. And she's going to focus on stormwater solutions in Oslo, so which are some experiences that they have, positive and some challenges, of course, that they encountered. So we will look forward to also hearing which are the lessons learned from all these implementations. So I'll then give the floor to Paula to give us her presentation, and if there are any questions, we will collect all the questions in the end of the session after we have the presentations from both speakers. So Paula, over to you.
Great, thank you very much. I'm going to share my screen. Hold on a minute, please. Hold on 1 second. Can you see it yet? No, you can't, can you?
Not yet.
Can you see it now?
We can see your screen and us.
Yes.
No,
Can you see
the
a PowerPoint?
presentation, yes. No, I think you're sharing another screen, not the presentation itself.
Okay, sorry. Hold on, everyone. Apologize. We've only done this how many times?
No problem.
Not enough, clearly, on my end. Sorry. Let's see. Okay. Now can you see my screen, my PowerPoint?
No, now we see your calendar.
Yeah.
My calendar. You can't see my PowerPoint.
No.
Sorry. Does anyone have a suggestion? I mean, I'm pulling.
I can start sharing my screen with your presentation, and I will give you access. So maybe that would do. So if you can just.
Sorry, everyone.
No problem.
I always have problems with Teams. So
yes, sometimes things can be a bit more challenging.
Yes.
So just give me a second to load the presentation, and then we will start.
So you'll advance my slides.
I hope I have the most updated slides from you. All right, so here I have the presentation. All right, so let me share my screen, and then you can require access to it.
That looks right.
Or I can also share the. Can you see it in presentation mode?
Yes, I can. Can everyone else?
The
Yes.
right presentation mode, right? Not the.
It's a good one.
Yes.
All right.
Yep.
All right. So then maybe I can just share, change the slides, Paula. So
okay,
you
great.
can let me know.
Okay, thank you. Thank you all. My name is Paula Kehoe, and I'm the Director of Water Resources at the San Francisco Public Utilities Commission. And we've been working on decentralized water systems for over a decade in San Francisco, as well as across North America. So I'm going to share some examples and things that we've been working on. Next, please. Just to provide a little background, we are a municipal public agency. We provide 3 utility services: water, power, and sanitation. We operate a combined sewer system in San Francisco where we collect both stormwater and sanitary wastewater in the same set of pipes, treat it and discharge it to the Pacific Ocean and San Francisco Bay. We also deliver water to 2.7 million people in the San Francisco Bay area. Next, please. We recognize that, let's see. Yeah, perfect. And managing these water supplies from a utility perspective is very, very challenging. We face a number of threats and uncertainties due to climate change, in particular drought in California, and on the West Coast is becoming more severe and more frequent. We also have extreme wet weather and flooding. We have aging infrastructure, and we have a lot of growth happening on the West, and in particular San Francisco and California. Next, please. And so we recognized that we needed to adopt a new approach to managing how we look at our resources, and really that comes to adopt a one water approach or a circular economy approach, not looking at our system from a linear perspective, but where can we maximize our resources and create more of a circular economy in San Francisco. Next, please. And really, when it comes to the topic we're talking about, that really made us think, how can we reimagine our water infrastructure in buildings, and buildings that are being built in San Francisco, as well as our landscape around these buildings. Next. And through that thinking was we wanted to recognize and acknowledge that buildings are actually sources of water. They produce different types of water sources: rainwater that hits our roof, storm waters, that precipitation on the streets or sidewalks and parking lots, also foundation drainage or nuisance groundwater. So in some areas of San Francisco, high groundwater table. We also have gray water, and in the U.S., gray water is water from our clothes washers, bathtubs, showers, and bathroom sinks. We don't consider kitchen water or kitchen sink water as gray water because most of the homes use garbage disposals, and so kitchen sinks are not included in gray water. Black water is all of the water that's considered to be wastewater or sewage that's normally discharged and treated at our treatment plants. And finally, buildings also produce condensate, very high quality water vapor that's collected from air conditioning systems. And so we thought about the opportunity to collect and treat this type of water on site, with either within an individual building or a small collection of buildings, to treat this water for non-potable end uses. And so in order to do that, we recognized we needed to address a number of initiatives. Next, please. And that really, before we got there, we also recognized there are a number of benefits for these on-site water treatment systems. So why would a municipal public agency who is in the business of serving water and treating wastewater want to encourage on-site decentralized water treatment systems that are going to be operated and managed by the private sector? And so from our perspective, we recognize that these systems have a number of benefits. They're climate resilient water sources for households, buildings, and neighborhoods. They can be flexible and installed very, very quickly. For us to build a project, a recycled water project, can take decades. These systems can be installed very, very quickly as the buildings are being built. Certainly from a utility perspective as well, it helps us alleviate water scarcity issues, and also can reduce the burden on our centralized infrastructure. Next. Is there a challenge with my volume? Sorry.
Yeah, sometimes we can hear your voice breaking a bit.
Today is not my day. I'm sorry. I'm having challenges.
It's okay. It's okay.
Yeah, I think we can still, yes, we can still hear what you're saying and the content, so that is fine.
Okay, I'm sorry.
No problem.
I guess really. But in order for us to really enable and deploy these kinds of treatment systems in San Francisco, as well as across North America, we had to address a number of barriers. And that really came down to appropriate water quality standards. What is the appropriate standard that needs to be set and achieved so these treatment systems can be protective of public health? In the US, we don't have any national or federal standards. We have some state standards that are very inconsistent and not necessarily protective of public health. And also there's a lack of guidance and oversight in management for, again, the ongoing protection of public health. Next. So in San Francisco, we decided that we were going to change this paradigm, and we wanted to really change how we always thought about infrastructure just from a centralized perspective. And so what we decided to do was, when we were building our new headquarters, which is shown here, we opted to include an engineered wetland treatment system with our building, within our building, to treat all of the black water that we produce in the building. And so on the outside of our building, you can see here a picture of some of the wetlands outside surrounding the building. This is an engineered wetland treatment system that captures the black water. Then the water goes into the basement of our building, and we disinfect that water with UV and chlorine. And then that water would go back into the building upstairs and flush toilets and urinals within our building. We've been able to reduce our potable water consumption by over 50% with this treatment system. And so again, we wanted to make sure that we could do it ourselves and in our own headquarters, as we see our headquarters as really sort of a living a laboratory and an area where we can explore innovation. Secondly, next, please. We recognized that if we wanted to enable, again, other buildings to do this, we had to establish a regulatory program in order to spell out the process for developers and the actions that needed to be taken. And so this ordinance is a partnership between 4 city agencies, us at the utility, Department of Public Health, very important in terms of issuing permits and water quality standards. Our Department of Building Inspection gets involved for installation of these systems, as well as Public Works for projects that involve pipes in the street and sidewalk. Next. We also recognize the need to streamline the permitting process to make it as efficient and effective as possible so developers could move through the process quickly. And so we've developed guidebooks and technical assistance to help, again, to help developers move through the process to install these systems. Next. Just to give you an example of the kind of treatment train, typically for gray water and black water treatment systems currently where we are right now, is that the typical treatment train consists of an MBR followed by UV followed by chlorine. And this is to achieve the log reduction credits and log reduction values that we've set out for virus, protozoa, and bacteria. And those are the 3 pathogens of greatest concern for public health for decentralized non-potable water systems. We want these systems to change in the future. We certainly recognize the opportunities for other wetland type treatment systems. That's why we're very excited about this work that's MULTISOURCE is undertaking, so we can get additional data and hopefully we can expand some of our example treatment trains to incorporate nature-based solutions. Next. And just so today where we are is we have a number of buildings. We have over 40 buildings that have installed decentralized water treatment systems. They're either in individual buildings like the one in the center is an apartment building, 550 units collecting gray water, using that for toilet flushing and urinal flushing in the building. To the left is a state-of-the-art sports arena collecting gray water, condensate, and rainwater. The bottom right is a district scale project that consists of 11 buildings, and it's a district black water treatment system. So different types of applications and installations in San Francisco. Next. Some of the common features of where we are today, since it is a dense urban area, is most of the treatment systems and tanks are below grade. So they're in the basement of these buildings. That's where they're located due to space. Oops, and in terms of where the systems are found. But next slide, please. We're starting to see that change slightly. We're starting to see that transform. This is an example of that 11th building a Blackwater district scale system. Actually, this is at grade. And they've incorporated a signage and encouraging people to understand that this is a treatment system that's that is for this project, for this redevelopment project, to provide non-potable water in the district in terms of toilet flushing and urinal flushing, irrigation, as well as cooling towers. And we expect to see more. We certainly see some product manufacturers building systems so they're more appealing and more meant to be installed in lobbies and other areas that are more public viewing rather than just hidden in the basement. So I think it presents an exciting opportunity looking to the future. Next, please. Yes. Just to provide a few other examples, we do have some rainwater and rainwater to a living green wall at a museum in downtown San Francisco. Next. We also have some other projects in terms of, here's an example of capturing stormwater and treating it for on-site restroom and toilet flushing and irrigation in a large park. Again, though the infrastructure is below grade here, but it is an opportunity to educate the public in terms of a large irrigation project. Next, please. And these next slides are going to be quick. I just wanted to touch on, though, that at the utility, we do provide a number of green infrastructure grants and projects that we've been doing throughout the city. As I mentioned earlier, we have a combined sewer system. So we've been promoting green infrastructure for stormwater management on a massive citywide scale. Next. This is just the next is a photo of series of photos of different types of applications, bulb outs, green infrastructure, different types of green settings throughout the city for slowing down the stormwater or enabling it to actually percolate into the groundwater system. Next. We also do promote gray water and rainwater on a residential scale. So we've been talking a lot about large scale, multifamily, mixed use and residential, but we are looking at smaller scale. We have, again, cisterns and rain barrels we provide to our community, as well as a gray water. Most common is laundry to landscape here in San Francisco. Next, please. We are expanding some of the concepts of potentially getting even more micro scale in terms of single family, looking at the concept of recirculating showers, looking at recirculating water and clothes washers, as well as single family gray water treatment systems. We hosted a State of the Science webinar last October of 2023 that's available on our website. And out of that came the need to actually have an independent expert panel assess some of the risks and feasibility of these kinds of application. And that report should come out later this month, and happy to share that report as it looks at some of the public health risks when we're looking at a single family setting versus a large commercial multifamily setting. Next, please. And just the last couple minutes, I just wanted to touch on the work that we're doing on a national scale. So we have a whole collaborative of public health regulators, water and wastewater utilities, as well as the U.S. EPA and the U.S. Army, who are doing a tremendous amount of work in the decentralized scale applications. And we also we formalized this partnership, and it's been a very exciting opportunity to really, again, expand the concept of decentralized water treatment systems throughout North America. We focus on public health, we focus on on-site oversight and management, as well as lessons learned. Next, please. So there are systems. Battery Park, for example, again, has had on-site water treatment, decentralized treatment systems since the early 2000s. Systems again are located in the basements of those buildings. Next. Also, just an example of at Emory University is a large-scale wetland treatment, engineered wetland treatment system, water hub to provide water throughout the campus. So different types of applications, again, similar to what is happening in San Francisco. Next. Just quickly, again, our key has been about water quality and how we have established this framework to protect public health, focusing on log reduction targets. Again, protozoa, bacteria, and virus are the most important pathogens of concern. And so we focus on that with the treatment drains, with continuous online monitoring. And again, with automated diversions and remote operations capabilities. So that the intent is that these aren't anywhere. They're not operated with an operator 24 hours a day. For example, operators just come a couple hours a week. So they're very highly automated systems. Next. And again, this path reduction target, just different target levels for different pathogens, whether and as well based on whether it's black water, gray water, rainwater, stormwater, and if it's for indoor and outdoor use. All of this information is publicly available. I'm happy to share all of this after the presentation. Next, please. We've really we have seen a market transformation. There's been several U.S. states and jurisdictions that either have current or proposed regulations based on our health risk-based framework in terms of our benchmarks, the LRTs. We're very excited again to create this consistency in North America. We have more technology providers on the market. We have more treatment systems that are indicating a return on the investment in less than 10 years. This is really comes down to skid-mounted treated systems, online monitoring, and remote operations. And we're finally seeing some that are incorporating other types of resource recovery, such as heat exchange and nutrient recovery. Next. We have additional work underway. We have recognized a lack of skilled operators, so we're developing a certificate program that will be online, hopefully in 2025. We're working with the plumbing codes, so we're creating consistency with ICC and IAPMO, as well as NSF for certification. We're sharing our lessons learned nationally and globally. For example, we just produced an use lessons learned book that talks about all of the lessons learned that we've had here in San Francisco. So I encourage you to take a look at that. Next. And we are continuing our work on the national level. I just want to point out one particular aspect is we're really focusing on looking at how we can incorporate nature-based solutions within our framework. We really want to encourage that. We're trying to work more closely with Jamie and your data. Hopefully we can get some movement in terms of nature-based solutions. As you've seen, most of them are gray infrastructure at this point. Next. And this, I think, is my last slide. Yes, it's really, again, our vision is for broad acceptance, really that we want to see decentralized treatment systems as just another appliance, reduced energy costs, and as well as energy to enable all communities to participate, again, emphasizing the nature-based solutions with these treatment systems, improve monitoring, as well as expanding resource recovery. And we also see the opportunity potentially for drinking water with these systems. In our headquarters, our engineered wetland treatment system is undergoing modifications. So we will be a site where we are actually going to produce drinking water from our black water treatment system. So thank you very much. I'm sorry for the fact that I couldn't operate my own slides this morning, but there are links to our programs, and I encourage you to take a look, and I'm happy to answer any questions after the presentation this morning. So thank you very much.
All right, thanks a lot, Paula, for this very interesting presentation. I'm sure that there are quite some questions that will arise. But before going to that, let's close the presentations today with Stina. So Stina, do you want to go ahead and give us an overview of the storm management practices in Oslo?
Can you see my presentation now?
We can, yes.
Okay, and you hear me?
Yes, we can.
Okay, good. So my name is Stina, and I work in the municipality of Oslo at the Agency of Urban Environment. That's the agency that is responsible for both implementation and maintenance of nature-based solutions. So I don't really work with gray solutions at all, so this will be all green. And in this presentation, I will talk a little bit about our experiences with implementing these solutions in an urban environment. And I will try to both go into detail and keep it short and understandable. So we'll see how it goes. I can change my slide. Yes. So Oslo is geographically limited by surrounding forests protected by law, the fjord, and the neighboring municipalities. And as a result, the urban development of Oslo is pretty compact. So as you can see from the map, a large portion of Oslo is forested, and in the bigger photo, you see the central Oslo with the fjord city development, which is pretty dense. So it's pretty green, but also compact. And with the compact city development, we face several key challenges in Oslo related to stormwater management. The first one being damage. High peak runoff rates and volumes lead to erosion, washouts, flooding. Second one being pollution. Rain events transport pollutants and particles into rivers and fjords and contributing to sewage overflow, as you can see here. And lastly, degradation of vegetation, because the urban development often reduces permeable surfaces, biodiversity, and carbon storage. So we, as every other city, deals with different rainfall intensities, ranging from low intensity rain to cloudburst events. And we have implemented this in our strategies, a dimensioning criteria called the 3-step stormwater approach. To mimic natural water cycles by using nature-based solutions. So the first step being infiltration, where we allow water to seep into the ground. And the second step is slowing down and temporarily storing water. And the last step is safe flood paths, ensuring controlled overflow in the event of a bigger cloudburst. And throughout this presentation, I will mostly focus on the step 1 solutions and some step 2. And a little bit about why my agency works with this, because historically stormwater management was the sole responsibility of the Agency for Water and Wastewater, which seems like the obvious choice. But however, after transitioning towards a more nature-based and open way to handle stormwater, we also have transitioned towards a more distributed responsibility for stormwater, so including us in the Agency of Urban Environment. And this shift encouraged us to think more strategically about stormwater in the broader context of urban planning. And a lot of people who never before had to think about this now have to. And so we have tried and failed a lot in our solutions, I will say. And one of our greatest challenges is the limited space available in the most urban parts of Oslo. Deciding what to prioritize, it requires balancing competing needs, because this might be the preferred way to build a street. You have room for everything, but most of our streets it works perfectly well for new developments like here in the fjord city. You can do mostly anything when you have a blank slate to start with. But most of our streets look like this, or this, and this. So what we mostly work with are smaller solutions like these to handle road runoff, and made properly, they work pretty well and are very simple. So I will now move over to our experiences, and some of the key factors for effective stormwater management include placement, ensuring that water flows into the right areas, sizing, designing solutions that can handle the right water volume, and then the inlet solutions, facilitating the flow of water into the system, and in some cases also out with an overflow, and vegetation, selecting the appropriate plants for stormwater absorption and management. And the last one, which I often think is the most important and way too often overlooked, is to preserve what we have and do some simple measures. When it comes to placement, and I must say, because I think this is different from many other cities, but also don't use groundwater for drinking water. We have other water bodies for that, so we can infiltrate, or in our strategies, we also infiltrate the road runoff into the ground, and therefore we often opt for making the runoff from the road as simple as possible, also into nature-based solutions. And in some cases, like this one, we must revise our plans to manage stormwater better. This initial design on the left for a rain garden between the sidewalk and an elevated bicycle lane would only manage the runoff from the sidewalk and the bike lane. Making the change of bending the bike lane and putting the rain garden between the bike lane and the road makes it possible to handle runoff from all the road, the bike lane, and the sidewalk, and making it handle a lot more stormwater and pollution and not getting it directly on our pipes, which are undersized. Some inlet designs that don't perform that well, especially on slopes, we see these issues. The worst examples includes curb drains on downhill roads that fail to capture water efficiently, like the examples on the top, the two on the top, and especially the one in the top right, where we have a curb inlet in a steep downhill and an outer curve. I think this might be Norway's driest inlet. And we also have issues with special solutions and special designs, especially if they are placed where people walk all over it. These channels embedded in the asphalt are static while the asphalt moves. So over time, the edges of the solutions can protrude, which the snowplow blade can catch on. And that has happened every winter since they were laid down. And these solutions, because they are special design, it's both expensive to replace and it takes a long time to replace them also. So what we see as the inlet solutions that works very well are the most simple ones. So depressions in the curb or just no curb at all, where there is a slope. A depression in the road itself usually works pretty well to stop the water so that it will change direction. And a lot of stormwater solutions, since they are usually limited in size, they have also an overflow. So when the nature-based solution is full and at capacity, it will overflow to the pipes. But the mistake we see way too often here as well is that the overflow is laying too low. Then you will not be able to use the height and the capacity of the nature-based solutions before it just overflows right away. So instead, the overflow should be lifted so that you can temporarily store water over ground, like in step 2, and make less of an overflow other places where it can make more damage. And when it comes to dimensioning the nature-based solutions, it's not always best to make it as big as possible. We see some places, like on the left, that the solutions is too small in comparison to how much water flowing in the streets, making them take up more space than they are effective. But they're integrated in the street pretty well here. And on the right, we have a rain garden, which is way too big for the amount of water flowing in the street. So it requires a pretty heavy rainfall pretty often to work properly and not dry out. So some summers we have seen that we have to water them. And when choosing vegetation for our stormwater solutions, we have to consider factors such as maintenance requirements. And mostly our solutions are very simple when it comes to vegetation because we have too few resources to maintain everything. So that's our main thing right now when it comes to vegetation. But you also have to think about root development, infiltration capacity, resistance to both moisture and drought, and the aesthetic function and pollution filtering capabilities. At this point, we do not have enough experience to say what works best, but there are a lot of testing going on. And we see also that the height and volume of the solution is very important, both for the space making and to prevent people from just walking all over them, especially during winter when you, as you can see on the top left, you can't really see them at all. So the last thing that I think is important is to maximize the green spaces and utilizing leftover areas. And we must try to preserve green spaces wherever possible. And they naturally contribute to stormwater management as they are. And additionally, leftover urban spaces can often also be repurposed for stormwater infrastructure. And the reason this point is so important to me is that I've seen a lot of horrific things been done where I think you could have had a very different outcome had you considered the green infrastructure from the beginning. Because when the municipalities started to implement stormwater infrastructure in their road upgrade projects, they started out with some bad ones. As you see here is a new street, and there is some planted trees and bushes to the right, which is great. But the street used to look like this, which I'll guess it handled a lot more stormwater than the new street design. So it's like you just made a plan from a blank slate and you didn't acknowledge the great green infrastructure that was already there. And the same goes for the streets, which some of you will maybe recognize as the site for the Oslo pilot in MULTISOURCE. And here the road project, when advertising for the new street has actually made it a point that there is innovative, great stormwater management on the side of the road to the right. But the street looked like this before, and even though, of course, there is a need for better infrastructure for bikes and pedestrians, I think it would have been possible to incorporate the existing green infrastructure better also in this project. So there's a lot of wrongdoing that has been done, but we have learned also, and those projects are older. And here's an example of the opposite, a newer project. I think it's 2 or 3 years ago. Jens Bjelkes gate. There are some very beautiful trees, and there was an upgrade of this street. And instead of removing them, they have got more space in the street, and we handle stormwater in the green spaces. And this street, which was never very nice to walk through, now is a little bit nicer. So when looking at the green infrastructure from the start, even though the purpose of this project also is for pedestrians and bikes, the outcome is a lot better. And lastly, here's an example of utilizing leftover space, a small parking lot in the middle of the city where there was stormwater issues, still is, but it's a little bit better. The entire parking lot has been made into a rain garden, which works pretty well. That was all that I had, and we have made a collection of examples which is available online. Unfortunately, it's all in Norwegian, but you can still look at the pictures. And it's also been upgraded during the summer with a lot more examples, but the new version is not online yet. So hopefully it will be soon and on the same link. And hopefully we will someday make it also in English. But there is a link here for anyone interested. And thank you for having me.
Great. Thanks a lot, Stina, also for this presentation. So maybe we can open now the floor for questions to Paula and also Stina. So please feel free to raise your hand or post your question on the chat. I think it would be nicer if you can unmute and ask, of course, but feel free, whatever it would work better for you. Are there any questions? I see that Anaklet would like to have the link here in the chat. Thanks a lot. Stina, any questions maybe for the presentation from Paula first that we had earlier? Yes, Jamie, please go ahead.
I have a question for Paula, because I think this is more of a climate-related issue. When you have your green infrastructure, your systems that are planted, and they're like based like on the buildings, do you ever come across the problem where you don't have enough water to keep your plants alive?
So in terms of, for example, if a building is treating its own water and using it for irrigation and they don't have enough water. Yes, so most of the systems have been designed so they have enough supply to meet their demand. We have a calculator, an online calculator, as a tool to help developers understand what types of volumes, again, from the various sources, and then their demands, their end use demands, whether it's toilet flushing and irrigation. All of the systems do have the ability for potable makeup water that can be added into any treatment system. You know, and all of that is, we have meters, so we understand how much potable makeup water is being used by a building. And we also have, in terms of, I didn't mention that we recently, well, in 2015, and then again in 2021, it became a mandatory requirement for these new buildings. Right now in 2021, it was reduced the square footage to 9,000 square meters, for example. Any building, multifamily, commercial, must treat their own water on site for toilet flushing and irrigation. And so they have to look to their own sources, whether it's an individual building or a district. And with that, we do provide, we do have a water budget allocation in our billing system, and so that limits how much potable water they can use. And then if they exceed that, because they turn their system off or it's down for some reason, they can get excess use penalties. So that serves as sort of the hammer to keep these systems going in the future and maintained properly. But they do all have the ability for potable makeup as well as connection to the sewer system if the water is out of spec, for example. It can be
Sure. No, it's just interesting because I was in Italy last week, and there was a green wall for a school, and there was a problem when the school shut down for the summer. There was no water. And so the plants died. They have to replant. And so I was just wondering, kind of, because it's probably a similar climate. I mean, when I was there, it was 35 degrees Celsius, 93 Fahrenheit, and it was the end of September. And it puts it into a different light, because you have to make sure that if you build these things, that there's kind of a backup plan to keep your green infrastructure green, right? So that's interesting. Thank you.
Great. Thanks a lot, Jamie. And I think that could also, maybe the same last question that you could also go to Stina. So is there like a backup plan when it comes to, because you're already investing in so much green infrastructure, and I guess you don't have the issue of having very high temperatures during summertime, but I guess that you might encounter lower rainfalls, for example. So is there a backup plan on reusing any type of water for watering these plants, or do you also then have to replace the vegetation itself?
Or if the winters are too cold and they die off?
Yeah, it's happened a lot. We have a lot of example with rain gardens that are they don't have a lot of vegetation because everything just died. Maybe it was planted too late in the fall. And also we have had some dry summers as well. I think one of the pictures of the big one is from one very dry summer. But I don't know if there's any backup plan. I think right now the approach is just to change it if it dies.
Yeah, I think also it's quite a common activity and approach to many places. Anacleto, I'll just give you the floor right after I read. There's a question from Mireille on the chat, so then I'll give you the floor. Are there any standards of treated water, the same whether you use it for irrigation, toilet flushing, cooling tower? So I guess, Mireille, this question goes to Paula.
So the how we approach it is depending on the source water, whether it's black water, rainwater, stormwater, foundation drainage, or gray water. We have an associated log reduction target for virus, protozoa, and bacteria. That those numbers, the LRT's actual number of removal varies depending on the source of the water. But the end use is all safe for any of those kinds of applications in terms of no non-potable applications. So, for example, LRT for black water is 8. It's much higher than it is if it's stormwater, or excuse me, if it's rainwater, for example. So the actual log reduction target number is lower, which translate to a reduced level of treatment. And again, so the treatment is all designed to meet the log reduction values in terms of remove the credits to remove those pathogens. And so, for example, a rainwater treatment system is usually just a UV system, a filter and UV, versus again, for gray water, black water, that's where we enter into a membrane bioreactor followed by a UV ultraviolet light followed by chlorine. So the treatment train is much more robust for gray water, black water than rainwater, but the water quality at the end of that treatment train can be used for the same end uses.
Right, so
Mireille, you're raising your hand. I don't know if you have any immediate reaction or. All right.
let's discuss it.
Then I'll give the floor to Anacleto.
Anacleto, we can't hear you.
I think there is an issue with his headset. No, I think it still didn't change to your. No, we can't hear you. Should I give the floor to Esther while you are fixing your? Yes, now we can.
Yes, yes.
Sorry. Just to add, there could be several questions. So thank you, Stina and Paula. Just to a quick reply also to the comment of Jamie, because it was not even that the school was closed, because it's our design, we know about it, but even that the backup with tap water was broken and wasn't fixed before the summer, and no one realized that was broken. So it's also a little bit more the barrier of who is doing what, especially during research project, in which is not fully clear the full responsibility of the monitoring of the green infrastructure. So a second level of the problem, not only the backup of the tap water. And for Paula, I have 2 questions. One that is detailed, and the other one more general. So the detailed one is in super decentralized reuse scheme, which is the frequency that you ask for monitoring, but it is not only a matter of treatment train risk, but also because we are starting to discuss in Europe, there is this indication for reuse from European directive, but some maintenance scheme is too much to be realistic for super decentralized scheme, because they are considering always the centralized approach. So no problem to have weekly monitoring or even bi-weekly monitoring of some parameter. That is not super realistic, or to have continuous monitoring of turbidity that for grey water treatment and reuse at household level is maybe not reasonable. And the second is more general also for Stina, because do you feel the need of having a scheme like Horizon Europe, but US Europe? Because I would love to have US demo case to compare, but not only research, but also the barrier. So all the barrier that Paula was presenting, this is general comment, is exactly the one that we are discussing now in CMM in another project about the sponge city of Milan. And most probably is the same discussion that Stina and the municipality of Oslo is having. So we really would like to have research project altogether, but this is more a comment than a question.
I'm happy to comment a little bit on monitoring and reporting, just because I agree that that is can be a challenging issue. So for us, we have again, depending on the water source, at the commissioning phase. So there's always a commissioning phase that we have with these treatment systems. There's more reporting. It's online reporting with the exception of bacteria, which just talk about in 1 second. But most of the data, and then it goes to monthly, and then it goes to an annual report. So it trickles down in terms of reporting. We provide templates, so we have templates that are available to the operators, so they fill in to try to keep things as simple as possible and as streamlined as possible. Bacteria has been a requirement historically for many treatment systems, because that was a common practice for total coliform when it came to black water and gray water treatment systems. That is a very costly test, and that currently is going to be eliminated in the state of California and many places. We did a report in 2017 that actually indicated that, and that was an independent expert panel report, that doing daily total coliform sampling is really irrelevant when it comes to on-site water treatment systems, because you're using the water before you get your results back. And so that whole concept sort of is an old concept that is being actually going away with this health risk-based framework. If you are constantly removing if you're monitoring your MBR as you should be, you're monitoring your online UV and chlorine, then you know that the treatment system is operating as it should, and that's what's providing that credit. And so you don't have to do endpoint monitoring for total coliform. So really shifting away from that. And our health risk-based framework guide that I showed a copy of really gets into that detail. I would encourage folks to take a look at that if looking at it from a regulatory perspective. I think it's very, very important. That's why we've spent a lot of time and effort from the public health perspective and regulatory perspective.
Great. I have a comment on the second more general comment that Anacleto had, but I'll give the floor first to Esther, and then I can comment on that.
Hi, thank you so much. I only have, well, first about what Anacleto just said, we are building here a green wall at IGRA to treat the grey water, and precisely today I went to check the construction, and they told me about this tap water backup plan, so that they put like a direct pipe that we can control like automatically. So it's something that, yeah, we didn't think that much about. And yeah, I only wanted to ask Paula if it's possible that we can access to this. You said that there is this platform to calculate for the end users to calculate if we could have access to that, if it's public.
Absolutely.
Thank you.
So I'll put the link. I just shared the link to the on-site reuse lessons learned, but I'll provide the link to all of our program materials. We have numerous technical resource documents. We try to organize them in a user-friendly manner. We don't always achieve that, but I'll send you San Francisco's link as well as our national. And again, I encourage you to take a look, and I'm also happy if you want to reach out to me directly. If you have any other specific questions, or you're trying to find something you can't find, or you want to connect with someone, happy that's part of our mission, is really to share our lessons learned and share what we're doing and how we're doing it, and the science, as well as the policies that are being developed. So happy to provide those links right now and in the future.
Thank you so much.
Great. Thanks a lot. Anacleto, do you want maybe to ask your question directly?
I have a question for Stina, if I still have time.
Yeah, I think we can take the last 3 questions. So I think it's one from Anacleto and 2 on the chat, I see. So we have one from Anna, and then maybe Anacleto, feel free also to ask the other question.
For Stina, thank you for presentation. It was super good. And I have one question. The short one is Oslo sewer combined or separated?
Mostly combined.
Okay.
There is a lot of separation projects going on, but it's very slow. So,
yeah, because the second question actually is, it was interesting that you have this direct experience on the in effective interception. Because for instance, in Italy, especially in the Lombardia region, the first of these intervention, because we are really prehistoric in comparison to you in Italy on this intervention, they were mainly driven by water utility, with their main interest in getting rid of stormwater from combined sewer, to not go have stormwater at the wastewater treatment plant, reduce the combined sewer overflow spill and whatever. So I have to admit that the hydraulic design was much more of interest during our project than the urban restoration approach. So and for the first bunch of intervention that we had the possibility to implement in Italy, I mean. So the question is, how was the interaction in your project as municipality with the water utility? So they are interested or not? They are co-financing this intervention? If yes, they are unhappy about the hydraulic design because maybe they have co-financed the intervention, they are not effective or not. So which is the relation that the municipality has in your case with the water utility for sustaining this intervention?
Yes, in Oslo, the water utility is also in the municipality, so it's just another agency. So we work together on this. So there's not a water utility somewhere else. So, but they want us to do this so that they don't have to get so much water on their sewage system. But it's all inside the municipality.
But they are not directly financing, because there is another big discussion that we are having, especially with CMM, if, I don't know, water tariff can sustain intervention on this or not. So the water utility should be directly involved in financing this intervention or not. So are you experiencing something similar?
Yes, they have like this directory where they can only finance it if it's beneficial to the sewage system, which I think you can say all of these are, but I don't know how they decide. Usually they don't finance the green infrastructure. That's on us.
So all the infrastructure, just to conclude the comment, all the infrastructure, the example, also the one in the PDF that you have shared, they were coming from urban regeneration project, not from water sector.
No.
Okay, good. Thank you.
Great, thanks. Thanks a lot. Anna, maybe do you also want to ask your question directly?
I mean, this is obviously a much more simple question, not so as technical as you've been having the discussion now. But now I'm just wondering, since we are going to have more and more warmer summers or warm summers, at what point is it actually still make sense to keep this kind of green walls versus like, having to add so much more water that can be used for other purposes for the green wall? So whether, yeah.
So yeah, maybe we can, I guess that Paula and Stina can have a comment on that.
I have to say, like in my agency, we don't work with buildings at all. So I don't have that much experience with green walls.
We have, a few green walls in San Francisco. I think that why we're just in terms of wanting more green in the city, whether it's green walls or nature-based solutions, wetlands, or other types of green infrastructure, is that we live in an urban center that has a lot of hardscape. It's heating up our city. It's very hot. And we want to incorporate green space and green amenities where we can. Certainly, just when we go into a drought, it's very interesting because how we work with our irrigation customers, for example, is we want them to keep a lot of green spaces green because those are places where people can go. So we're always trying to balance and look for opportunities for non-potable water, non-potable uses of that water for irrigation to keep our green spaces green. But we do think about that, and we think about how we can strategically manage our water and water supplies to use the right water for the right use.
Perfect. Thanks. Thanks a lot. And also looking at the time, I don't know if there's any very last questions to Paula and Stina. All right. So then I only have maybe a comment that links to Anacleto and how we can also ensure that the examples have also a global reach. You, Paula, mentioned that you are now developing the lessons learned report, and you also mentioned that you are interested in the examples, also the results from the monitoring from MULTISOURCE. So I think that would also be an interesting result from our projects, and how we can integrate the findings from MULTISOURCE also into such kind of reports, if there is the space there, for example. So please let us know. I mean, we are also now reaching to a stage of the project that we do have a lot of data, and I think Pedro can then also, of course, give you more information about that, as he is also the one who is leading and having a very good overview of all the data that we have gathered. So I think it would be also very interesting to see how we can also share our results and enrich as much as possible also why to use nature-based solutions or such approaches when it comes to manage water. So happy to do that, because I mean you already in your presentation shared many interventions that we are also piloting within the project. So happy to share the lessons learned. So I think it's up to you to let us know how we could do that.
Yes, thank you. Absolutely. I've been emailing, Jamie and I have been in the email exchange. We are really looking forward to the partnership with MULTISOURCE and continuing the data. Again, having additional data is so critical for us to enable other alternatives in our treatment systems and incorporating nature-based solutions. So we're very excited about this opportunity, and happy that we can share what we've done from our perspective here in the US. So thank you very much.
Thanks a lot. Jamie, did you have an immediate reaction to that?
No, it's actually it goes both ways. I mean, we're excited to share our experiences with you, Paula, and we're also, I mean, you've done already so much work on the on-site treatment systems and kind of how that governance structure can look like. And like we were talking with Anacleto, you know, it's a model. It's a model that could be imported to Europe because we're behind. You guys are like light years ahead of us. And so I think there's a mutual benefit to seminars like this, to webinars, to having these discussions and looking at how can we come together to go forward. So it's exciting.
Great a lot. So maybe we can extend the invitation to, once the report is ready, maybe you can share some of these key highlights from that report. In any case, we are planning to have more splashdown sessions in the upcoming months, also with other projects in Europe. So that would mean that we also have a wider reach to other cities and organizations. So that would also be very interesting to hear. All right, so then I think if there are no other questions or comments that I missed also on the chat, I would like to thank very much Paula and Stina for this very interesting conversation, and all of you, of course, for participating and having such an interesting discussion. We will share with all of you the presentations, and then of course I think that there are the contacts of both Stina and Paula within the presentation, so feel free to reach out to them if you have any additional questions. Yeah, so thank you very much, and see you next month in the next session.
Thank you so much.
Thank you.
Bye.
Thank you.